Time for day 7. Day 6. Day 6 was a little rough. I mean, in general, it was fairly simple. But one of those weird things that kind of hung me up. We'll see how 7 goes. So far, we have half as many people completing these as we did on the first day. We'll probably see these numbers continue to drop, especially if we get to something overly complicated. Remember in the 2018 one, I think we hit, it was like pathfinding, or there's one where you had to like calculate the 3D distance between satellites. That one was a little tricky. You saw a huge number of people drop off after that. But these people may be, completing these at their own pace. So we should see these numbers jump a bit, but we'll probably still see some reduction of people completing these, which is fine. People can certainly do these at their own pace. They don't have to do this, try to complete it as it comes out. But for me, I like the fact that it does have a sort of, see how fast you can kind of do it, kind of competitive nature. Kind of forces me to work on these. I probably wouldn't do these in general. I'm not a huge fan of puzzles. But for all the programming puzzles, this one is definitely my favorite. I love the lack of focus on optimization. You get into the HackerRank or the other ones, and they, your solution has to be, super optimized. This one, it's like, there are some cases where you do have to optimize things. So, you can't always take the super brute force method, because you may just never get your solution. Or, if it takes you like an hour to run your solution, it's going to be a huge pain to fix it if it doesn't work. So in some cases, you may need some knowledge of, I guess, having an alternate method than just brute forcing it. And that comes from that like search space kind of stuff. Knowing when to make assumptions, knowing about certain algorithms, or using the right data type, or not searching through your input too many times. Yeah, some people find some crazy efficient methods of solving these. If mine is, sub-second, that's usually fine for me. All right. So I'm ready for day 7. We haven't seen, looks like our little ASCII art. Looks like we've got to our island. I think from yesterday, what were we doing? We're filling out some customs form or something. I guess we'll see what happens once we actually get onto the island. All right, you land at the regional airport. We're gonna get our luggage, do the regulations, Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently, nobody responsible for these regulations considered how long they'd take to enforce. Light red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain 3 bright. Okay. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags, and so on. You have a shiny gold bag. If you want to carry it into at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? In the above rules, the following options would be available to you. Bright white bag, which contain your shiny gold bag directly. So in the example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. How many bag colors can eventually contain at least one shiny gold bag? Okay, so we need to parse this into a list of rules. How many bag colors can eventually contain at least one shiny gold bag? So let's see. What can we do? Maybe a class here. Bag can have a color and it can contain other bags. Let's call this bag rule. I guess we need to recursively go through these rules until each color bag contains all the rules under it. For this, we would need to have we should end up with a list of bags. Well, actually, we just need to know whether it can get to shiny gold or not. So we need to what are we looking at? think really all we need is maybe a list of colors. And then whether they can contain gold or not. Hmm. So how are these rules broken up? First it's the color, and then it has the word contains, and either no other bags or a list of different bags below it. I guess we should figure out how to parse this. We need a color, and then maybe a dictionary of what it can contain. Are we going to see duplicates in here? It should be a unique color for each line, I believe. Let's see. I'm going to use some regex to parse this line. Our colors are always going to be 2 words. So that first match is going to be our color. And then we're going to have contains. And then the rest of our match is going to be what it can contain. The bag rule color equals matches. Should this be match? Group 1 maybe? Can't remember if that's group 0 or group 1. I think it's group 1. And then we need to parse we need to parse this. So for each of these, content starts with no, then it's not a color. Otherwise, we need to we're going to match this with the pattern number and then color. So we should first have the number, 2 words, and I think that's all I need. Yeah. Then it's going to say bags, but we don't need to capture that. So let's see. So bag roll contents add. We're going to add so the first one is going to be the color, and the second one is going to be the number of bags. No, wait, I got that backwards. There we go. One. All right, and then all right. So when we're done, ideally we should have a list of bag rolls. So let's use our practice content. Let's run our program on that. I'm surprised it didn't give me an exception here, but I guess that's okay. So we got, first one is a red bag. The contents are one of bright yellow and one of muted yellow. One of bright white. You know, I'm actually kind of surprised that that worked the first time through. So we need to recursively go through these. So we need to do something like this. Can contain gold. So let's see. So we should eventually get to something that says no other bags, ideally. dotted black. Okay, hopefully there's no loop in here, but I'm sure there isn't. Let's see, so let's see if any of the contents equals shiny gold. If the contents have no other bags, return false. Else you know, this can be a dictionary. It'll probably make this a lot faster. Dictionary of dictionaries. No. Why are you being weird? So instead of this, we're going to say all right, contents. There we go. And then down here, let's see, for each bag in this needs to be what, a color? Content in bag, if what am I doing? No, that's not the proper way of doing this recursively. That doesn't seem right, but what are we doing? We're counting the number of bags that can contain at least one chili bag. So our count should be bags count Yeah, I didn't think so. The given key, bright white, was not present. Oh, that's right. Bright white. It should have been in the bag. Did I screw up parsing? Let's see, my list of bags. Bright white, bright white. Why isn't bright white in here? Oh, you know what? These don't have the right names. Why am I one off? This shouldn't say red bags. Let's see, groups. Red bags, red bags. What? Why didn't it capture light? Oh, because this needs to say bags right here. Light red, okay. What do you get, 4? Okay. So let's try that with the input. We get 348. Is that correct? Wow, it apparently is. All right. Part 2. It's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Faded blue contains 0 other bags. Contains 0. Contains 11. So a shiny gold bag must contain 1 dark olive bag and 7 bags within it. A single shiny gold bag must contain 1 dark olive bag. Where does it say that shiny bags have to contain anything? shiny gold bags contain 1 dark olive bag. Okay. So a single shiny gold bag must contain 1 dark olive bag and 7 bags within it. 32 bags in total. Of course, the actual bags have a small chance of going several layers deeper than this example. $126. So let's try this and see if we get this 126 thing. Whoops. Let's switch out our input. Let's disable problem 1 for now. We want to test, we want to recursively go through and count the number of bags. Let's see. Maybe I can spell right. Here we go. So kind of similar to or can contain gold. All right, so we're going to have our bag. Oh, we need to have a running count. So if we get to a bag that says that it can contain no other bags, then we're going to return our running count. Otherwise, we are going to count each path below and add it to our running count. So for each bag rule or content inside of our bag, we're going to add bag counts to it. And then when we're done, we're going to return the running count. Ooh. Wait. How can I... Should I be passing the running count around like this? We'll see. So what do we need to do? We need to return the shiny bag count. Shiny gold. We'll start with a count of 0. We didn't get any numbers back. Why? Let's see, our list of bags. So we start with shiny gold and we should go to dark red. So for each content, which is a dark red bag, we want to count dark red and pass in our running count of 0. Let's, what is step out? Shift F11. So running count, why did dark red give us a 0? We're doing dark red, we have a running count of 0. Do we need to count ourselves? Is that the trick? You know, we're we're not actually counting anything here. Do we? So a shiny bag must contain 1 dark olive bag. Oh, you know, we need to count. So we need to count first this bag, which would be content.value. And then we need to add in everything below it. $54. That's not even close to being correct. What am I counting? I'm trying to get 126. So how the heck did I get 54? So maybe I should pay attention here. I got 54. So let's step through this. So shiny gold and then dark red. So we should have a running count of 2, the 2 dark reds. And then this should take us dark red contains 2 dark orange bags. Dark orange contains 2 dark yellow bags. It makes sense. Wait, what are we doing here? Oh, we need to do this for each bag, not... We need to do a bag count for every time we get across one. So let's see. So we want to do running count. And then oh, jeez. One dark and 7 other bags within it. Hmm. Should be simple, but I'm getting hung up on something here. One dark olive bag, two vibrant plum bags. Dark olive contains 7 other bags. It's a weird way of counting. One dark olive bag and 7 bags within it, plus 2 vibrant bags. And 11 within each of those. Hmm. So it first contains the value, the content of the bag, plus the content times what each one has below that. One dark olive bag and 7 bags within it. Hmm. Ooh, doggy. Let's see, running count. Would I send down the running count? Or no, I just want to add. Yeah, maybe it should be like this. And then the running count should start a fresh one. 100, there we go. Okay, I think I got it. Yeah, that, well, let's see if I got it correct first before I start talking about it. Okay. Yeah, the thing was that running count right here. Well, there's a couple things. I needed to first, so I start at the shiny bag, and then I get to each of the contents in there. So I count the number of bags. So if I have 2 dark yellows, I add 2. And then I need, for each of those 2 bags, I need to count every bag within it. But when I start off, I need to pass that running count as 0. Do I need to pass the running count at all? No, I did not. I don't know why I was thinking that. Yeah, I didn't need to do that at all. I guess I was kind of thinking of other recursion problems. I didn't need to create this class. I really just needed this dictionary. And then, yeah, this small amount of code was it. But, yeah, it certainly gave me a lot of problems. Ooh, what happened here? How am I doing? Ooh, I guess I wasn't the only one having issues. It looks like a lot of people took quite a lot of time to do this one. My rank went up quite a bit compared to what happened yesterday. So I guess I wasn't the only one having issues with this. It is I guess you can call it a basic recursion problem. $348, was that the right answer? Puzzle answer was 348, okay. So I do have some pretty slow. There's probably a faster way to do this. I don't like seeing that. We have a dictionary. That's fine. Well, that's it for today. Took what, 40 minutes? Yeah, didn't do too bad. Looks like I went up in the rank a bit. But yeah, they're getting a little bit harder. We got a little bit of recursion today. We should see. Yeah, and we did have to worry a bit about parsing. I guess regex makes this pretty easy, but if you wanted to try to parse this with doing nothing but line splits, or like, you know, splitting by a space, that would be quite a bit of a pain. Luckily, regex makes these things pretty easy. Yeah, so we have a pretty compact looking solution. Definitely not the most efficient if we're getting anything more than 0 milliseconds for this. But yeah, that's it for today. We'll see how tomorrow goes with Advent of Code. Day 8 is tomorrow on our trip to the island. Okay, that's it.